And you are all welcome to this special session. Like I indicated to you, today we have a guest lecturer, and in UMaT, we are actually trying hard these days to make sure that we bring industrial partners in as guest lecturers sometimes, so that together we can learn, and then we also help bridge the gap between academia and industry. So this morning we are privileged to have Engineer Isaac Boakye. I would say that he's a personal friend. We work together as executive committee members of IEE Ghana session, somewhere between 2010, 2011. He works with the Ghana Aviation Authority. He's a licensed engineer and also a senior member of IEE. He is the current industrial liaison officer for IEE Ghana session. So trying to liaise industry and academia with over 15 years of professional experience. So we are really privileged this morning that he's here. He is passionate about anything networking. And so he's very happy. If I don't even take care, he will want to take the rest of the topics, but which is not allowed. So engineer, if you are there, most welcome to our class, Data Communication and Networks. This is level 300 students, University of Mines and Technology.
Thank you very much, Dr. Mrs. Millicent Aganjiba. I'm privileged to be with you, friends, and for the lectures to go on seamlessly for all of us. I will be very glad if all of us sign some contracts, as it were, so that we will have little distractions as the lecture goes on. So if you will permit me, I will want to set some ground rules that may help us. For the purpose of our friends who may find themselves in locations where mobile networks may not be too good, I will plead that you put your video off so that it doesn't degrade the bandwidth that we are using. 2, if you are not speaking, I'll be very glad if you can mute your microphone. If it is time when some questions have been asked and you want to show a PC or ask some questions, please feel free to raise your hand electronically and then you'll be called. If at any point in time during the lectures, you hear something and you might want to ask a question about it, you can either write it down so that at the tail end when you are doing the discussions, and then you can ask, or you can use the chat feature to ask your questions. All right, so as has been said by Dr. Millicent Aganjiba, I'm assisting her on the team transmission media that falls under data communication and networks. So in today's lessons, what are some of the things that we are expected to know before this lecture ends? First, we will get an understanding of what transmission media is. And then we will discuss the types of transmission media that we have available. Because there is not a single transmission media, how then do you choose which of the transmission media after we understand it to achieve what you want to do? Then we will talk about the types of the transmission media, looking pictorially, some physical examples, and I will try very well to relate it practically to you so that you can get a better understanding of it. And then when we get to the other type of transmission media, it will take us to another environment that we will call the wireless or free space. Then we see whether we can have some classification if you want to use the free space to achieve networks. But then of course, you also be given something to go and read about So now, as you are seeing on the screen, this is a typical example of a transmission medium. But then, of course, you remember the OC model. The OC model, we have 7 layers. We can talk about the physical layer, the data layer, link layer, the network layer, the transport layer, the session layer, the presentation layer, and the application layer. So a transmission medium, we are saying that it is something physical. It's something located below the physical layer. So as you are currently seeing on the screen, you see physical layer, sender, physical layer, receiver. And beneath this, we are seeing transmission medium. So we can say that if physical layer is 1, then transmission medium will see level 0, as we are seeing on the screen. Then it's a transmission medium. A transmission medium can be broadly defined as anything that can carry information from one source to a destination. So, for example, assuming that you have 2 people who go to a restaurant to eat, but as they communicate, what do you think will be the medium through which they will communicate? Remember the definition of a transmission medium. We are saying anything that can carry information from a source to a destination. So if these 2 people at this restaurant, then person A becomes a source, person B becomes a destination. And as they communicate, how is it possible person B hears person A? That possibility of person B hearing person A means that whatever information coming out of the mouth of person A now can be heard by person B. So the medium through which his information from person A gets to person B is classified as what we call the transmission medium. Of course, in written message, we can say that the transmission medium can be a mail, carrier, a truck, or an aeroplane when it comes to letters. But of course, because we are talking about data communication, let's get what it means when you talk about transmission medium. So in data communication, the definition of the information and the transmission medium is more specific. The transmission medium usually can be free space, as we have seen, as in the example of 2 people communicating at the restaurant. Or it can be through something physical that we can see, we can touch. And we can call it a metallic cable or a fiber optic cable. That information is usually a signal that is the result of a conversion of data from one form to another form. What then are the types of transmission medium that we have? So in telecommunication, transmission media can be divided into 2 broad categories, as we are seeing on the screen. The first category on the left is what we call the guided or wired media. It's guided because information that flows through this medium has a defined portion that carries this information. It's guided because it's physical. We can see, we can touch. The other type of transmission medium, as seen on the right, is what we call the unguided medium or wireless media. We say unguided because you cannot guide the information compared to the first situation where it is guided. This information is available all around us, and it's actually in free space. So when you take a powder and you throw the powder in free space, can you define where the powder will go? I guess not. So with that understanding in mind, think about that information. Once you send it through free space, you cannot guide it. but then it should be able to get to its destination. What then are some examples of wired or guided? So we are saying that guided or wired media are those that provide a conduit from one device to another. It's important to take note that a guided media or wired media are those that provide a conduit from one physical device to another. And as you are seeing on the example on the screen, we have the copper media and we have the fiber optics. Under the copper media, we can talk about the QuasiCable and the twisted pair. What about the unguided media? Well, we have two categories. We can talk about the fixed and we can talk about the omnidirectional. Now, when you say fixed, what do we really mean? Fixed. Well, in communication, if we want to communicate information through free space from a source to a destination, usually we employ the use of antennas. So we can fix one antenna as a transmitter, and at the receiving end, we fix another receiver. What is the point? We are saying it is fixed because the transmitter and receiver must directly see each other. Does it necessarily need to be at the same height and the same level? Probably not. So one instance, the transmitter can be this high and the receiver can be this low, but they must see each other, provided there's no obstacle in between them. Another instance, the transmitter can be this low, the receiver can be this high, and they must see each other. So when you send information from the transmitter, the information through free space must be able to get to the receiver, provided there's no obstruction in between. On the other hand, omnidirectional means from one point you can send to so many points. Omnidirectional because the information radiates or moves around the antenna equidistantly, carrying the same power around. So if I send a signal through an omnidirectional antenna and the signal has a power, say 5 watts, and it can go, say, 100 meters, it means around the antenna, 100-meter radius, you will get the signal around it. So again, as said earlier, transmission media, we have two types, the wired and the wireless. The common transmission media we have around us usually is the wired media. So in our homes, we can see them. We can see QuasiCable because it's QuasiCable that we use as TV antenna cable. In our homes, we also see twisted pair. Twisted pair because if you have a telephone line in your home, then you have a twisted pair cable in your home. But then, nowadays, telephone companies are migrating from the use of twisted pair to fiber. We will soon discuss why that trend. So, for instance, the network with which I am connected talking to you this morning is through a fiber. So in my home, if I look behind me, I see a twisted pair cable. I look on my TV ahead of me, I see a QuasiCable. And I look on my right, my telephone termination, I see fiber cable. And it's the commonest in terms of cost. So we have it all around us. We also talk about the wireless media because it is wireless, because it employs the use of free space. It employs the use of radio frequency waves. It employs the use of microwaves or infrared light transmission. Now, when you talk about radio waves, I'm sure most of you are very much aware what radio waves are. Think about your mobile phone device. Your mobile phone device. I don't have any antenna connected, but then I'm able to make a call or receive a call. How is it possible? Because of the radio waves through free space, unguided, wireless, that is connected to the cell site that establishes a connection to me, to you, when I make a call. Now, we talk about microwaves. Please, dear friends, we are not talking about the microwaves of your mom. No. We are talking about a type of antenna. Now, if you have ever seen a telecom mast, you would have noticed some huge white antennas that look like a drum. Yes, those antennas are called microwaves antennas. And they are used to send information from either point to point or multi-points. Of course, infrared light transmission is also around us. And in your various homes, think about TV remotes. TV remotes. Do you notice that there's always an LED, either embedded or you physically see it? Now, have you thought about what happens when you press the remote? It's able to connect to the TV to instruct the TV based on the commands you are issuing on the remote. So if I press 1, the channel changes to 1. It is communicating to the TV wirelessly. What are the criteria for one to choose which network media to use? Well, these are the caveats we need to take into consideration. First of all, let's talk about the distance. Theoretically, some of the transmission medium has rated distances that it can successfully carry its signal. Well, 2 friends, Kofi and Kojo. Kojo probably can eat 4 balls of kinky, and Kofi maximum can eat 1 ball of kinky. So if you ask Kojo and Kofi to go and work, who do you think will have more energy? And who do you think can work most? I'm sure Kojo, right? Because Kojo can cover more, can do more, can cover more distance because Kojo has more energy. Very soon, we will appreciate this example between Kofi and Kojo, one eating 1 ball and one eating 4 balls, to relate some characteristics of transmission medium. So some of the transmission medium, you cannot go far. When you put the information through it to send it from one source to the destination, it gets to some point, the information cannot go again. Some can go beyond where the first got to. Some can go beyond where the second got to. Some can go beyond where the third got to. And in fact, even going, the amount of information that it can carry also has to be determined. And that is a characteristic we will soon talk about. 2, we also need to consider what environments are you going to install this transmission medium. So if it's a factory floor where you have a lot of electromagnetic inductions from motor, what kind of transmission medium are you going to use? Let me give you a typical example. In your homes, many of you who may not be using proper QuasiCable, have you noticed? I mean, now with the color televisions, with the modern smart TVs, it's not very common. But in the olden times, when we have this color TV but with the big hunchback, you may notice that if your mom is blending in the kitchen, you will see the screen of the TV rolling down. And you will be wondering, what is happening? It's clear all of a sudden, why is this looking so green with the screen rolling down? There is induction. The environment is that very close to you, there's an induction device that induces into the transmission medium. So to determine which transmission medium to use, you need to determine the environment that you are going to use it to see how much interferences you have in it and how much that device can tolerate the interferences. The third thing you need to consider is the amount of data that the transmission medium is going to carry and at what speed. Again, Kofi, Kojo at 4 balls, Kofi at 1 ball. If you ask them to pack blocks, I am sure Kojo can pack more blocks than Kofi. At the end of the day, the amount of blocks that Kojo and Kofi can carry, we will say that is the amount of data that can go through this medium. But at a point in time, you will realize the speed with which Kojo will be carrying the block, because he has little energy, will be slower than the speed with which Kojo will be carrying the block. So how much you can carry and how far you can go also need to be determined. But above all, their costs also need to be considered. Then, some characteristics of transmission medium. Of course, cost is very important as a first note. Cost. How much does the media cost? By far. The examples have related thus far. You will see that QuasiCable, which is the TV antenna cable, is very common. Very easy to locate, are all around us in our neighborhoods. So probably might be cheaper. But then, twisted pair is more cheaper than Quasia. Even fiber optic cable is not that expensive. It's very cheap. But a fiber network is very expensive because of the transmitting and the receiving devices that need to do the transducing. That is where the cost is a value. Cable itself is very cheap. So without the transmitter and the receiver, converting the light energy to the information you need, the fiber cable itself is useless. So the cost must be considered. What are the installation requirements? How difficult is it to install? How much experts do you need to deploy? What is the convenience to install? That all falls under the installation requirements that we need to consider. We also need to talk about the bandwidth. I will soon explain what the bandwidth is. We also need to talk about the band usage. And under the band usage, which is different from bandwidth, we're talking about two categories, the baseband or the broadband. And then we talk about an interesting friend called attenuation. The reason why Kofi will give up earlier than Kojo. Kofi ate 1 ball, Kojo ate 4 balls, and you want them to do the same work, Kofi will give up early because of attenuation. Then the last characteristic we need to consider is immunity from electromagnetic interference. You remember the example I gave concerning? You'll be watching TV, and then once you hear the blender come on, there is some rolling lines on your screen, TV screen. Or if your mother or sister is a seamstress that has the electric sewing machine, once it is on, you will see that there will be an electromagnetic interference that will reflect with your TV screen lines rolling down. And then, of course, sometimes when a car ignition is parked very close to it and it's turned on, you will see these electromagnetic interferences. So let's see if we can discuss some of the characteristics that we have mentioned. And the first we want to discuss is the bandwidth. What is bandwidth? Band and width. Band and width. Question. Assuming I ask a couple of you to walk through a standard door in Ghana, how many people, if you are walking side by side, can walk through this door at the same time? Well, some might think, say one. That is correct. Because if one person walk through, at the sides of this person, there is still free space, isn't it? Somebody will say two. Yes, true. If two people are to walk through, and in fact, the standard door in Ghana is 7 feet by 3 feet. So two people walking through, walking side by side at the same time. Yes, when they look at their left, there will still probably be some space, right? There'll probably still be some space. Has it achieved the understanding of bandwidth? We are getting there, but not yet. What about 3 people walking through? Well, there might still be some space at the side, but okay. What about 4 people? Then you will realize that if 4 people are to walk side by side, they cannot walk through the door. At best, maximum 3 people walking through the door, walking side by side. Although there will be some little space left and right, they can walk through. So what then is bandwidth? Bandwidth, we are saying, is the information carrying capacity of a medium. How much information can go through this transmission medium at a go from the sender to the receiver? So in computer networking, it can also refer to the data rate supported by a network connection. And in this case, if I design a network and the maximum bandwidth of the network is 20 megabits per second, I cannot receive information beyond 20 megabits per second, but I can receive information less. It's the same way, although the capacity of a door is 3 people, 1 person can walk through, there is enough bandwidth. There's enough space, so it's okay. So how then can we measure bandwidth? Well, from the lowest to the highest, we can say that we can measure bandwidth bits per second. Bits per second. And we're talking about bits, we are talking about zeros and ones. So if I have 0, 0, 0, 1, I am talking about 4 bits. In mathematics, if I mention 0, 0, 0, 1, then of course it's 1, isn't it? Because preceding zeros before a digit, it's not counted. But in binary digit computation, in computer networking, all zeros before a preceding number are counted. And of course, the far left is the least significant bits, and the right is the most significant bit. So 0001 is 4 bits. It means these 4 bits can go through per second. As you go higher, then you can talk about a kilo bits. And a kilo means 1,000. And in computer, a kilo is 1024 bytes. So kilobits per second. So it means if that media 1024 bits of information parallel can go through at the same time. I'm not talking about series. If I'm talking about series, then we are saying that one go, another is following, another is following. No, we are talking about parallel. They are walking side by side and they can go through the medium at the same time. So from bits to kilo, that means kilo is more than bits. But as you increase the bandwidth, then you can talk about megabits per second. And that is the commonness around us. Most of your networks, if you go to the computer lab, you want to check your network's data connectivity speed, it's usually rated in megabits per second. And this morning, before I connected, when I checked my speed, I realized that I was somewhere around 94 megabits per second. Crazy, eh? Yes, it's because I'm using fiber.
Wow.
If I were to be, I heard somebody say, wow. And please mute your microphone before there's a background noise. So if I were to be using the twisted pair cable to still have the same connectivity, then I will probably be hovering somewhere around 4 megabits per second. That straight away tells you that the amount of information that can be carried through a fiber is way higher than a twisted pair. But the more crazier aspect speed, we talk about gigabits. So bandwidth is responsible for data transfer speed. Therefore, the bigger the bandwidth, the faster the connection, and the quicker the information upload and download. So at 94 megabits per second, that is my download. That is how much tunnel connectivity, direct connectivity I have with my telephone network provider. So as I am streaming to you, that is the bandwidth that is available to me. So you may see that it's seamless. I seem to even be underutilizing my bandwidth. What if I want to send information to upload something to the network? That is my upload. And my upload, I have control. It's usually always higher than the download. So if my download is 94, then you can imagine my upload. So in electronic communication, of course, another understanding of bandwidth is that it is a range of frequencies that an electrical signal uses in a given transmission medium. So in radio wave communication, it also has a bandwidth. And the bandwidth, we have its lowest frequency up to its maximum frequency. So in mentioning some of the bands within the electromagnetic spectrum of radio waves, we can talk about very low frequency, we can talk about low frequency, we can talk about medium frequency, we can talk about higher frequency, we can talk about very high frequency, we can talk about ultra high frequency, super high frequency. These are all bandwidth within the electromagnetic spectrum. Question: what is bandwidth measured, or what is the SI unit of bandwidth? As rightly seen on the screen, it is hertz. But then mentioning hertz, do you also remember another parameter that has the same SI unit? Frequency. Does that mean that frequency is the same? Well, the relationship of hertz, which is frequency with time, is that they are inversely proportional. So with frequency, we are talking about the number of occurrences of repeating of a unit per time. So remember a sinusoidal signal. If you can see my video on, you can trace my hand to get a glimpse of what a sinusoidal signal is. I'm sure you got it right. Well, so from the start to the end, it's one cycle. How fast it starts to the end is the time. So the frequency is inversely proportional to the time. The higher the frequency, the smaller the time. So the higher the frequency means the higher the bandwidth. If the bandwidth is big and you are carrying information through it, within a short time, it gets there. That is what it means. The higher the frequency, the shorter the time. And the time here is what we call the period. And the period is the duration of a time of one cycle in a repeated event. That is why we say that frequency is equal to 1 over T. Frequency is equal to 1 over T. The relationship between frequency and time is that they are inversely proportional. And frequency is the bandwidth, and time here is a period. How long it will take the information from the source to the destination from the transmitter to the receiver. If the bandwidth is big and I want to upload a 5 megabyte data, 5 seconds is uploaded. So let me give a typical example. Now you know my download 94 megabits. My upload, let's just for convenience sake say that 90 megabits per second. Another person has a bandwidth of 60 megabits per second. And a third person has a bandwidth of 30 megabits per second. If we are all to upload a data of 5 gigabytes, please, who do you think his data will upload faster? A with 90, B with 60, or C with 30? I'm sure your guess is as good as mine. Because A has a bigger bandwidth, it will take a shorter time to upload. Bigger bandwidth, inversely proportional to period, means bigger bandwidth, smaller, the smaller the time. I'm sure you get that understanding. Well, what about the band usage? The band, well, it usually occurs in 2 ways. We talk about the baseband, and we also talk about the broadband. The baseband, we say, is the common mode of operation. And we said that with the baseband transmission, the entire capacity, the entire bandwidth is used to communicate with another channel. So with a baseband, if the information carrying capacity of the medium, as in the case of a door, the maximum carrying, the maximum number of students that can walk through at a time is 3. So what is the bandwidth of a door? Is 3. I hope you get it. So the bandwidth, so from the sender to the receiver, with a baseband, the maximum capacity of the medium is used, dedicated between the transmitter and the receiver. But with the broadband, now most of you hear broadband communication, broadband communication, broadband communication. All these telecom internet providers will tell you, oh, we provide broadband services, broadband services. What are they really talking about? We're talking about when we enable 2 or more communications to share the bandwidth that is available at the same time. So in the case of baseband, the medium available is 50 megabits for megabits. Example is 50. And this 50 is dedicated between the sender and the receiver. But in the broadband, this 50 megabits is not dedicated to only sender and receiver, but is dedicated from a sender to a number of receivers. It means within this medium, the information contained therein is not only from device A. So the medium is 50. We have device A and device B. It's dedicated, whatever device A sends, only device B receives it. That is dedicated. But for a broadband communication, as seen on the screen, in the first example at the top for baseband, you see the computer on the left. So the channel, as we see on the screen of the channel, is dedicated between the sender and the receiver. The same scenario is true when you look at it here. The data information is dedicated between the sender and the receiver. But in broadband, the same capacity is available not only for this man alone. So you can have 3 devices sending their signal or data through this medium at the same time. I am sure you get the concept of it. Maybe this program may explain it better. So we are saying baseband, the available medium is dedicated between a sender and the receiver. Now in broadband, the same capacity of the same medium is dedicated not to just a sender and a receiver. It allows multiple senders to send their data through this medium to their destination. Now, so by thus far, we have attempted to talk about some characteristics of transmission medium. So we have talked about the bandwidth. Now, we've talked about band usage. Let's attempt to talk about attenuation. But before we talk about attenuation, remember I gave an example of Kojo and Kofi. Kojo can eat 4 balls of kinky, and Kofi can eat 1 ball of kinky. So question, what is the capacity of Kojo with regards to kinky? Or what is the bandwidth of Kojo when it comes to kinky? 4 balls. It means Kojo can eat 4 balls of kinky at a go. That is the maximum. What about Kofi's bandwidth? 1 ball of kinky. I'm sure you get the understanding of what bandwidth really means. And with baseband, we are talking about how the entire capacity of the medium is devoted between the communication channels. In the case of the baseband, it's dedicated between a sender and a receiver. But in the broadband, it enables 2 or more communication channels to share the bandwidth that is allocated. But then, the medium through which this available bandwidth can be shared uses a technique, one of 3 techniques. One of the 3 techniques, we are saying that we can either do that by employing the frequency division multiplexing, time division multiplexing, or wavelength division multiplexing. And that is what will be given to you to go and read about as a homework. Now, let's talk about another interesting characteristics. Attenuation. Attenuation. Remember the example again. Kojo, because he has a bigger bandwidth, can eat 4 balls of kinky. Probably he can work longer. Or if they are walking, he can walk further. Kofi capacity is 1 ball of kinky, the least. Possibly, if they are working, he can work less. Or if they are walking, he can walk less. Why? The amount of energy in Kojo will keep propelling him to walk more. So what is the point in relation to attenuation? We are saying that with attenuation, you see, when a signal is being propagated along a transmission medium, the moment it leaves the sender as it's going, it gets to a point, the energy carrying this signal begins to get weak, and it gets weak. And it reaches a point, no matter what you do, the signal cannot go again. At that point, when the signal has gotten weak, that it cannot go again, we say that it has gotten weak because it is what? Being attenuated. What then is attenuation? We are talking about the gradual reduction of the strength of a signal as it moves along a transmission medium. That is attenuation. And whether this signal is a digital signal or an analog signal, it can be attenuated. So when you talk about attenuation, we can talk about the gain or the loss. But usually when we talk about attenuation, we are more interested about how much power has been lost. Now let's go back here. Now look at this example. The first example where we have the computers at the left and right. From the computer on the left, assuming that I send a signal of 10 watts, I'm expecting the signal to get to the destination. Probably it gets to 2/3 of the medium, the signal cannot go again because it has been attenuated. Now the power of the signal that I am sending at the input here, I call power 1. The power that I'm expecting at the output here, I call power 2. So if I want to measure how much power I have received at the end, then I need to compare how much power I'm receiving at the output here and compare it to how much power was sent initially. So it will be power output, power input. The power input is the source, PD, and the power output is the destination. So you compare the destination power as against the input power to know how much of your signal has been lost. All right. So I have just seen somebody saying that he didn't really get the concept of baseband and broadband communication. So let me quickly review it and then we move on. If you still don't get it, probably at the end of the class, you can ask again. So with baseband and broadband communication, it's related to bandwidth. So we are saying that we have a transmission medium. And this transmission medium that we have, we can send information through it by a decision we need to make. The decision we need to make is to employ it as baseband. In that case, all the capacity of the medium, we dedicate it to only one transmitter and one receiver, as in the case of this. So here, as you see in the third picture down, so let's say from the top here to the down, the third picture down. Now look at the top and down. If the amount of information that can go through this barrel is 20 megabits per second, in a baseband, we are saying that we are dedicating this channel from the source to the receiver 20 megabits. It's available. It cannot be shared. It is dedicated because only transmitter A and transmitter B have this channel available to them. But if you want to talk about broadband, then this same available channel, we don't want to dedicate it for only one channel and one receiver. We want to employ a certain technique where the same amount of originally transmitter A will send to transmitter B. This time around, the same data will still available to pass through. But then we don't dedicate it to only transmitter A and transmitter A and receiver A. This time around, we use transmitter B, receiver B, transmitter C, receiver C, to say that, well, we want to save costs. We don't want to buy, because first we only have transmitter A, receiver A to use this transmission medium. And this transmission medium, think about that we have two computers, computer 1, computer 2. We decide to connect computer 1 and computer 2 using a twisted pair cable. Now this time around, I have more computers. So instead of dedicating the transmission medium to only computer A, receiver A, now because I have computer B, receiver B, computer C, receiver C, I don't want to go and buy another transmission medium. The medium that I have, is there a technique I can use where the data that I am sending will not be affected, but transmitter A, receiver A, transmitter B, receiver B, transmitter C, receiver C can share this available bandwidth and still not lose the amount of data I can send? Is there a technique I can do that? Yes. And you can use this technique to share the available bandwidth that you have. So once you are sharing the available bandwidth between transmitters and receivers, then it's no longer baseband. Baseband means dedicated to one transmitter receiver. Now, because I am sharing, it's no longer baseband, but it's now what? Broadband. I'm sure the person who has the question now gets the idea. Well, I'm sure attenuation, also you have gotten it. Attenuation, we are saying that is the gradual reduction of signal power along a transmission medium. And we usually compare it by knowing how much power has been received at the output and compare it to how much power that has been received at the input. What about electromagnetic interferences? So electromagnetic interferences simply are external noise that disturbs the signal that we are sending in the transmission medium. Remember, a transmission medium is not dedicated to only the physical cable we are seeing. Free space is also a transmission medium. As in the case of the example I gave concerning watching TV, but because there is a blender being blended, an electric machine being used, or the ignition of a car being toothed, you get these lines on your TV rolling from top to down. Because it is an induction inducing an electrical signal to the original signal you are receiving from your antenna through the cable to your TV. This external signal finds a means to affect the signal inside the cable. The reason why you are getting these lines. And that is electromagnetic interference. We also have another phenomenon we say crosstalk. Now, crosstalk usually happens in communication, voice communication systems. And the typical example is our telephone lines. Friends, sometimes have you noticed that if you have a telephone in the house, it is actually not a perfect situation. It is when there's a mistake, that is where crosstalk happens. And when it happens, you pick the cradle of your telephone handset, you want to make a call. You have not dialed the number yet, but it appears as if some people are talking in the background. You can hear people communicating. And you kind of ask yourself, is your telephone line connected to another person's telephone line? Or is someone elsewhere using your telephone lines? So to the common people, they go and complain to the telecom company and say that, somebody is using my telephone line. My bills is not correct. Review it. It is crosstalk. Crosstalk usually happens when pair of cables appear as if they are one. This is what I mean. I have one pair of cable. A pair means two pair together, transmit, receive for one person, another pair, and then there is a third pair. So I have three pairs now. Now, when I want to make a call, it's dedicated. This person wants to make a call, is dedicated. The third person wants to make a call, is dedicated. Now, this time around, because there's a problem, this third person picks the phone, he wants to make a call, and he's hearing the first person's call. That is crosstalk. This happens along the transmission medium when there's probably a defect along the line, and the signal carrying the power carrying the signal begins to loop around this bunch of cables, forming an electromagnetic induction around these cables. And when it does that, it makes these cables around that point all appear as if it's one cable, just one pair of cable. So with crosstalk, we say that security becomes less since anybody's communication can be heard. Now, let's talk about some of the guided media, since I've already mentioned a number of them. Let's talk about some of them. As seen on the screen, we have the QuasiCable. And in the QuasiCable, we have two types. We have what we call the thick net, and we have what we call the thin net. Of course, looking at the names, thick, thin, thick, thin. It means QuasiCable, as you know, is the TV cable. Some of them are very thick, and some of them are very thin. So to some of you, when you go to the market, you want to go and buy a TV cable. The same cable, TV cable, usually about 100 meters, you ask the price of one, they will tell you 70 Ghana. And you go and ask the price of another one, they will tell you 350 Ghana cedis. And you kind of, okay, then give me the 71. Well, remember, the characteristics will not be the same. The amount of data it will carry will not be the same. Its quality will not be the same. But generally, we are saying thick net carries more data than thin net because of its configuration. We also have what we call the twisted pair. Twisted pair, we have two categories. We say we have one that is shielded and another one that is unshielded. And then, of course, we have the fiber. I'm sure most of you who have seen a QuasiCable in your homes have not had it open, so you don't know the composition of it. Now, on the screen, this is how a typical QuasiCable looks like. So when you cut open a QuasiCable, these are the things you will see. First, you will see the outer jacket, usually white or sometimes blue, but the commonest one we see for our TV is white. This is the outer jacket, it's plastic. Now, directly below the outer jacket is an insulator. It's an insulator because it doesn't allow electric signal to pass through. Why do we put the insulator here? Well, just after the insulator, you will see a mesh of wire that is braided together. As you can see, the lines, a braided mesh. This braided mesh is one of the two metals that is available to the QuasiCable. And then just after the braided wire mesh, there's another insulator, insulating it electrically from the metal that is inside, which we call the inner conductor or the inside metal. In fact, it is this metal, the inside metal, that we connect to the adapter that plugs into the TV. So all your TV signals, your DSTV signal, multi-TV signal are actually coming through this inner conductor. What about the outer braided mesh here? It serves as a return path, trying to block external signals that will interfere. So the more quality of this metal, the more quality of this braided mesh, the better the insulation of the external electromagnetic interferences coming in here to cause that signals rolling down the screen. So QuasiCable exists in two forms, the thick net and thin net. It is very, very easy to install the thin net because it is thin compared to the thick net. It's very easy to bend around. It's very easy, it is lighter to carry than the thick net. It is cheap in terms of cost. Thin net is very, very cheap to buy than thick net. In fact, when you want to compare how much data that can be carried through, the thick net can carry more data. In fact, nowadays, if in the olden days, we used to use QuasiCable for even computer networking. But nowadays, that CCTV camera has come to reach us. If you don't use the twisted pair, now the commonest is using the thick net for your CCTV cable installation. And it can carry more data than the thin net. Now, when you compare how much interferences of electromagnetic induction to thin net to thick net, we will say that to a reasonable degree, it is better with thick net than thin net, although both are not entirely immune to electromagnetic interferences. And a typical example of a thick net and a thin net is what you see on the screen. Now look at the thin net, the inner cable, the inner metal, and compare to the thick net. What do you see? It is thick because it's big. Bigger means it can carry more data. So with the thick net, you will see that it is rated 10 base 5. With the thin net, it is rated 10 base 2. Now 10 base 5 because it's telling you the 10 is how much speed, the capacity it can carry. So with thick net, it can carry 10 megabits. The bandwidth is 10 megabits. In thin net, also, the capacity is also 10 megabits. But then, did you take note of the varying speed here between 2.5 and 10 megabits per second? So, although it is rated 10 megabits per second, but you will realize that you will not really be getting 10 megabits per second. Now, what about the 2 and the 5? What does it signify? It is telling you how long it can carry its data before attenuation sets in. So in the case of a thick net, if you want to use it to send information from a source to a sender, its distance is only 200 meters maximum. For thick net, 500 meters maximum. For thin net, 10 meters maximum. For thin net, 10 meters maximum. For thin net, 500 meters maximum. For thick net, 500 meters maximum. For thin 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 net, 500 meters So what are the installation requirements? So if you decide that you want to, in my house, for instance, I'm using a DSTV, and the other side also is a DSTV. Now, because I want to share the cost with the other side, we use a thick net cable to do a certain configuration that is allowed by DSTV, so that we have what we call the dual view. So instead of paying for Compact Plus, instead of me paying for Compact Plus about 250 Ghana cedis a month, and my other friend also paying 250 Ghana cedis a month, we are now paying, both of us are paying about 300 Ghana cedis. So we share 151, which is cheaper than 250. But then both of us independently can control our decoder, and we get the same channels that are available to us because of the distance. In fact, where I am to where it is, it's less than 100 meters. But because I don't want a signal to degrade, that is why I opted for thick nets. So this is a typical or a practical examples of the use of this QuasiCable. What about twisted pair? Twisted pair. Well, the first one we want to talk about is a shielded twisted pair. Maybe I think that when you talk about unshielded twisted pair before you talk about twisted pair, maybe you understand better. Unshielded twisted pair. Look at the picture. Now we have one cable red, another cable ash. We say twisted pair. Pair is what? Two. These two cables are twisted together, and they are inside an outer plastic cover. So from my telephone line, one cable serves as a transmitter, and the other cable serves as a receiver. But of course, we can also configure it such that it can also carry data. In the case of normal telephone internet connectivity. Now, we look at it critically. After the pair, you see, this is the actual cable. This cable has plastic, the red one has a plastic insulation around it to physically prevent it from physically touching the ash one. That also has an insulation around it. Both are twisted, and then both have an outer covering. Now let's compare. This is what we call the unshielded twisted pair. It's a twisted pair, and it's unshielded because there's no protection between the pair and the outer. Now let's look at the twisted pair, the shielded. Please, what difference do you notice? Do you see the difference? The same pair of cables around has a metal shield, a braided metal shield. But between this insulation of the twisted pair is another insulation, and then a twisted metal shield, and then the outer plastic covering. So, what do you think? The cost of shielded twisted pair and unshielded twisted pair, which is more expensive? Of course, shielded twisted pair is more expensive than unshielded twisted pair. What about attenuation? Which of them do you think that the signal will easily get attenuated over long distance? Of course, it makes sense to say that unshielded twisted pair will attenuate at a shorter distance as compared to shielded twisted pair. What about the available bandwidth? We can say that the bandwidth of shielded twisted pair is much higher than unshielded twisted pair. In fact, the bandwidth of an unshielded twisted pair is 60 megabits per second if you want to use it for a token ring network. And although not immune to electromagnetic interferences, we say that it is fairly resistant to EMI. EMI means electromagnetic interferences. than unshielded twisted pair. What about twisted pair? Of course, cost is cheaper compared to shielded. Attenuation, easily attenuated for long distances as compared to shielded. What about the ease to install? It's very, very easy to take around to install unshielded twisted pair than shielded twisted pair. What about bandwidth? Bandwidth requirement is lower compared to shielded twisted pair. What about electromagnetic interferences? It is much affected. You see, because there's no braided wire mesh, you see, the braided wire mesh serves as a path that returns to Earth. So when there's an external interference coming in the case of the shielded twisted pair, this wire mesh gets the signal and then returns it to Earth from affecting the signal here. Although it is not immune to it, to a reasonable degree, it does this way. But if you compare to unshielded twisted pair, it doesn't have it. And the commonest computer networking cable we have around us is the unshielded twisted pair. The unshielded twisted pair. And we have about 7 categories. So the commonest one we have that we use for our computer network is what we call the Cat5. So in fact, like I said, there are 7 categories of shielded twisted pair, Cat1 to Cat5. This is a typical example of a picture of an unshielded twisted pair. So we have the cable and we have the connector. The cable is the Cat5 cable. The connector for unshielded twisted pair we call the RJ45. So the RJ45, we have the female and we have the male. So if you want to create one, as we see on the one with the blue color, you slot the cables. Now you see that inside the female has 8. So in fact, the blue cable for unshielded twisted pair, you find 8 cables, but 4 pair. 4 pair. Because it's 4 pair, it's 8. So the female has 8 slots. You slot in cable nicely and then use a tool called the crimping tool to tighten it, and then it locks it like you've seen it in the middle, and then it becomes your UTP cable. So as seen on the screen about the categories of UTP cables, we have the Cat1 to Cat7, and as you see, the category 2 is what we normally use for our telephone networks. That has a bandwidth of about 2 megabits, 4 megabits per second. The Cat2, the Cat3 has a speed of about 10 megabits per second. Cat4 has about 20 megabits per second. And the Cat5, rated at about 24 American wire gauge, has about 100 megabits per second. So if you design a network from a switch through a UTP cables to your computer and you want to check the speed, by default, you will see 100 megabits per second because that's a maximum. But nowadays, there's also advanced Cat5, which can carry about 125 megabits per second. And of course, we have the Cat6 and Cat7, depending on what you want to do. What about fiber optic, the third example of the guided media? And at this point, please give me about a minute. All right, friends, thank you for your patience. I am back. So, fiber optic cable. Well, in a fiber optic cable, now as you see on the screen, you will see a sender and then you will see a receiver. In between, this big box is the fiber cable. This fiber cable itself is very, very cheap. But when you buy this very, very cheap cable, what can you use it for? It's actually nothing. But to be able to create a fiber network, then you need the sender and the receiver. So a fiber optic cable is made of either glass or plastic. And this transmits signals in the form of light. So these fibers use reflection. So you see, they transmit signals in the form of light. So the sender, you arrange a photodiode that converts your information to light and send it through this fiber. And you see, inside the fiber, it has an outer jacket we call the cladding. But in between is the portion where it carries a signal. Now, if you remember in light, in physics, when we talk about total internal reflection, so this sender shows the light at a certain angle where the signal begins to reflect by the light through this core. The core is the area that defines the bandwidth to send the signal. So a glass or plastic core is surrounded by a cladding, which is less dense. So the difference in density of the two materials must be such that the beam of light moving through the core is reflected off the cladding instead of being refracted into the core, into the cladding. Now, what are some characteristics of fiber? Now, you appreciate why we say fiber has a bigger bandwidth. Now, with fiber, we say signals travel in the form of light using the principle of reflection and refraction. But also, we say that Shadrach, ACN, you left your microphone on, please. Thank you. I'll just muted you. So, although fiber cable is cheap, by in whole, we say that fiber is expensive. Expensive because of the sending and the receiving transducers. Unlike twisted pair and QuasiCable, you need to be trained how to install fiber cables. So we say it is difficult. In terms of attenuation, we say that fiber cable is not affected at all by attenuation because the information within the fiber is light. It's not signal. Because it's not signal, it does not affect light. Now look at the bandwidth. The bandwidth is the highest, and it can carry up to 2,000 megabits per second. It is not affected by attenuation at all. Take notes. It is not affected by attenuation. And in the case of QuasiCable or fiber or twisted cables, where sometimes you find corrosive, it's corroded. I remember last week, my multi-TV wasn't coming. I climbed up and I realized that water has entered to the where I connected the splitter, and so it has blackened and it's corroded. But with fiber, it is resistant to corrosive material. Is it not true that glass is more resistant to corrosive material than copper? At this point, we have talked about the guided media. We have talked about twisted pair. Twisted pair, we have the shielded twisted pair we have the unshielded twisted pair. We also talk about the QuasiCable, where we talk about the thin net and the thick net. And then we also talk about the fiber optic cable. Can we then talk about the other category of the transmission media, the unguided media or wireless communication? Unguided media transport electromagnetic waves without using any physical conductor. And that is why we refer to this type of communication as wireless. And air and free space is what it's employed in the use of wireless communication to send data from one place to another. And it's not guided, it is just through free space. Although it is directed, the signals are beamed. Whether you are using a directional antenna or an omnidirectional antenna. A directional antenna means that you have directed the maximum beam of the signal to face a particular direction, so that once it is seeing the receiver, whether the same height, this way or that way, they must directly see each other so that the signals guided can move from the transmitter to the receiver. In certain times, it is not directed. In that case, we say that it is omnidirectional. From one antenna, the signal is radiated equal power around equidistance of the antenna. We can use radio waves as well. We can use microwave antennas, and we can use infrared as well. Thank you. Well, what are some reasons why we use wireless technology? We use wireless technology in certain instances where it is practically not possible to use a physical cable to connect from one node to the other. Example. Let me use an example of, say, Standard Chartered Bank. I don't know whether, Takwa, you have Standard Chartered Bank at your end. Doc, can you please confirm the popular bank in Takwa?
There used to be, but I think they didn't stand the competition, so they left.
Oh, nice. Please, which is the commonest bank in Takwa?
ABSA, EcoBank, you know.
Okay. So let me use EcoBank. Thank you. Now, EcoBank is headquartered in Accra. Think about it. Now, EcoBank in Takwa, if I want to send Dr. Millicent money now, all I need to do is to pick my phone, use the EcoBank app, and send the money. From where I am staying in Accra, how is it possible? See my phone. There's no physical cable connecting to the EcoBank service in Accra Central. Neither, I don't know how it's connected to Takwa. How is it possible to be able to do that seamlessly? Of course, you appreciate that from my phone, it's wirelessly through the telephone network backbone. But let's talk about EcoBank itself, the headquarters. How are they connected to EcoBank, Takwa? Please, is it possible that they can dig the ground and pass a fiber cable from Accra to Takwa? Well, somebody will say, well, I may use that. But wouldn't attenuation setting, wouldn't it be too far? Well, at some point, the signals may degrade. But at those points, what do? I may need to pick the signals that have gotten weak, re-energize it, and retransmit it. So if I do that, what would then be the total cost connecting between Accra and Takwa? Another requirement for choosing your transmission media, which we didn't talk about, is the link budget. Of course, we talk about the cost, but the cost, we didn't go too deep. We talk about the link budget. You break it down to do cost analysis. You also take into consideration how much data are you going to carry? the amount of data you are going to carry will determine the type of topology you are even going to use. And I'm sure somewhere in our presentation, we may touch on it briefly very soon. So we use wireless because there are certain environments, like maybe from Accra to Takwa, it may be practically impossible to dig the ground to pass a physical cable from Accra to Takwa. So probably that we employ wireless technology. And when you say wireless technology, three things: infrared, microwave, and radio. As for infrared, we should not even think about it because theoretically it's for short distances. Microwave, probably yes. But microwave also has this limitation. At some point, the signals get weak. If it is analog transmission using microwave, at some point, you need to re-amplify the signals before you transmit. That is why GTV from Accra is able to transmit to Tamale. But if it is digital transmission, where in Takwa you are able to receive digital transmitted signals, of course, to some extent, it also signals are also get weak. But the beauty of it is that digital signals are unaffected by external interferences. It is only the signals that get attenuated. So you use what we call the regenerator amplifier to reboost the signal and retransmit. So if I am transmitting an analog signal, say 5 watts, to Takwa, by the time the signal gets to Takwa through free space, although my transmitted signal is 5 watts, in Takwa, I may possibly be getting 18 watts. Why 18 watts? 18 watts because of external interferences that have added itself onto it. You see, signal itself is analogous. So in free space, there is a phenomenon where signals in free space can add itself onto another signal, especially the signal that has a stronger power swarms or capture the signal with the lower power and send it across. So the signal with the lower power will still get to its destination, but at the destination, it's not only the original signal that has been sent that gets there. It gets there itself for other unwanted signals. So if it's analog transmission, at the receiving end, you need to find a means to remove the unwanted signal. In this case, I send 5 watts, that is unwanted. At the destination, I am getting 18 watts. So how much unwanted signals am I to remove? 13. Look at it, very, very high. It means my receiving circuits need to be well designed. Otherwise, this unwanted signal, which is even more than the required, will burn the receiver. But with digital transmission, I send 5 watts. Although I'll be amplifying at my destination, what gets there, it doesn't get there with the unwanted signal. What gets there is exactly the 5 watts that I sent. Now you see the advantage of a digital transmission over analog transmission. The reason why most governments are encouraged to go digital. So it's more convenient to install wireless communication between Accra and Takwa compared to using cabling. Now, people will move around a lot within their work environments. So, for instance, your work environment, you still need to be connected to the network in the office. And of course, you cannot be physically connected by cable. You take your UTP cable on chiller twisted pair cable, plug in to the RJ45 port on your laptop, and you'll be carrying around getting internet connectivity. No. You use wireless. So that through wireless 802.1.11 ABC, you're able to get your signals connected to your device. Another reason why we use wireless technology is sometimes for temporary installations. Now, where I work, we have systems installed all around Accra. And even at the airport itself, some of the systems that helps to land the aircraft are installed around the runway. The runway is the road on which the planes take off and land. But then the engineers, technicians cannot operate, go and sit in those by the systems and be operating them. We need to find a means to be able to control this equipment comfortably at the office. Some of them that are not too far apart, we have been able to do that using a fiber cable. But some that are far apart, we do that using not temporary, but permanent, using either microwave or radio wave. Another reason why we use wireless technology is that people who travel outside of work environment and need instantaneous access to the network resources need to have access wirelessly or wiredly. But wirelessly most of the time, because now we do more of wireless connectivity than wired. Are there some advantages and disadvantages using wireless technology? Well, the advantage is that it helps you, the user, to be very mobile. It's very, very easy to set it up. Cost is very, very cheap because you already have the infrastructure already embedded with your device. And the infrastructure is already embedded in the transmitted device. All you need to do is to do the configuration and you are connected. It is expandable, meaning that more devices or more nodes can be connected. Now, these advantages, if I compare it to wired or guided media, then you are thinking about a computer network. Maybe you go to your computer lab where you have physical wires, UTP wires, connecting from the switch to the network port of the computer. Then you will see that if the capacity of the switch is 24, it means only 24 system units or computers can be connected to it. That's all. Nothing more, nothing less. Setup, you need to connect physical cables from every port on the switch to the computer. And it's not fast. And when you finish, you need to do configuration. And of course, it comes at a cost. And it's easy to move around because you might get trapped or tripped by a cable. So I'm sure you appreciate the advantages of the wireless technology. What about disadvantages? Well, they can be, security can be poor. Security can be poor because there are devices now that can eavesdrop your bandwidth frequency in free space. Wireless can be affected by EMI. Of course, you can have inconsistent connections. Let me use my case to explain the inconsistent connection. For the past 1 week, I have observed that anytime I put off my laptop and bring it on, my wireless adapter keeps going on, off, on, off, on, off. Initially, I thought it was a problem from the service provider. Then I realized that no, why don't I reinstall my wireless driver to see whether the problem will be resolved? That I did, and the problem was resolved. Then I realized that, oh, the problem was rather coming from my wireless adapter. But it stays on after a while, then you see it disconnects. No, it disconnects. Then after a while, it connects. Inconsistent connection. What have I done around? I went to a computer shop. Since I didn't have the cable, so I just went to a shop to buy an already designed cable. Now I connect from my fiber switch directly to my laptop used through the RJ45 connector. That is what I have done now. So if I compare the speed when I'm connected wirelessly to the speed when I'm connected by a wire, then I see that indeed wireless technology, the speed can be low. Because when I connect wirelessly, I'm getting around 40 megabits per second download. But when I connect wiredly, I'm getting about 94 megabits per second. Now, this is what I talked about. That you want to connect EcoBank Accra to EcoBank Takwa. We need to take into consideration, how are we to connect from Takwa to Accra? We can do that in 3 ways, but we need to make a decision. How much bandwidth do we need? Automatically, once the bandwidth that we'll be using to carry the information from Accra to Takwa is less than 3 megabits per second, the only choice we have is to employ what we call ground propagation. The propagation, we are talking about how the information will be carried from one point to the other. And if the information we want to carry, the maximum bandwidth is less than 3 megabits per second, we cannot employ any other means than to use ground propagation. But when the bandwidth of the signal we are going to propagate is between 3 to 30 megahertz. So I think in this particular picture here, it is 2 megabits per second and 2 to 30. It has been updated. For ground propagation, it is below 3 megabits per second. So please take note, below 3 megabits per second. And for sky propagation, it means once my bandwidth is between 3 megabits per second to, so I think it's correct. Anything less than 3 is actually 2. And anything from 3 to 30 is 2 points. It can be 2.1 to 30. So I think it's correct. So once my bandwidth is between 3 to 30 megabits, I can now use what we call sky. But if my bandwidth is more than 30 megabits, then I can only employ a propagation called space propagation. Space propagation. But space propagation is mentioned line of sight propagation here. Let me explain in a brief. So for ground propagation, we're saying that frequencies less than 3 megabits per second. Now remember the relationship between frequency and distance. Frequency is inversely proportional to distance. Once it's inversely proportional to distance, what it means is that if the frequency is low, then distance is high. If the frequency is high, then distance is low. So between Accra and Takwa, the distance is high. Once the distance is high, if I use a higher frequency, the signal cannot probably get. If I want to employ ground propagation, then I may need to use, if I want to employ ground propagation, then it means I will install one transmitter and one receiver, and it uses the ionosphere. It uses the ionosphere so that the signal can go very, very far. But then, because the frequency is a measure of bandwidth, how much information that can be carried, then you realize that, oh, for band information, the band data or the required is huge. So if I use a frequency less than 3 megabits per second, it means I cannot carry enough information between Accra and Takwa. So it means if I want to go by ground propagation, it is not possible. Although I can go very far using ground propagation, the bandwidth will not help me. It cannot carry this amount of information because with band, there is picture, there's fingerprinting, there is a lot of info data. So it means I cannot use ground propagation. Well, what about, why don't I employ sky? So in ground propagation, it means when you send your information from one transmitter to the receiver, the information follows the curvature of the Earth, and it can go very far. So you see the telephone mast. You see the telephone mast, the signal is just lower the surface of the earth and it can go very far. Although there will be obstructions, the signals in free space, you always find its available space and just keep going. But when the signal is between 3 to 30 megahertz, it means I can only employ sky or space. If it is sky, it means the bandwidth is between 3 to 30 megahertz. It means I have a transmitter and I'll send my signal to the sky. If I send my signal to the sky, the ionosphere behaves as if it's a mirror. The signal hits the sky and it bounces back and it can be received at the receiver. In that case, I put one transmitter that has an antenna, probably a satellite dish, and I send through free space, it hits the ionosphere, it reflects, and then it gets to my receiver. In that case, I can reach Accra and Takwa. What if in between here, the clouds are so dense with rain droplets tapping the signal? The signal will be impeded. That is why with sky propagation, when the rain clouds become dense with water droplets, their signal drops. That's why when it is raining, you are watching DSTV, multi-TV, the signal cuts off because the rain droplets forms a dense and it blocks the signal going. What about if the signal or the bandwidth is more than 30 megabits per second? Then I employ what we call space. It means space propagation because I have put a reflector in the sky. And this reflector I put in the sky, I will call a satellite. So satellites usually goes beyond the ionosphere. I send my signal to the satellites. The satellites receive the signal, processes, amplify, and sends it back to the receiver. And it is all line of sight because my satellite transmitter must see my ground transmitter must see the satellites. If it doesn't see the satellites, transmission will not go on. Once it sees the satellites, transmission successfully goes on. Now from the satellites, it is also transmitting to my ground receiver. If it doesn't see it, reception cannot go on. That is why we can also call it line of sight. So in between the types of propagation below 3 megahertz or above 30 megahertz, these are the available electromagnetic bandwidth that are available to us that I mentioned earlier on. Very low frequency, medium frequency, high frequency, very high frequency, ultra high, super high, extra high. Now, what are the classification of wireless networks? Maybe as you look through with the bands, you will see the maximum bandwidth it can carry. Very low frequency, these are the maximum bandwidth of frequency. Low frequency, medium frequency. These ones you don't usually see, but especially in oceanic communication, it is there. They use it a lot. Because these frequencies are very low, the signals can go very, very far. So in some old radios, you see the AM radio. When you tune it, very noise, and you can even get very far off signals. But the higher you are going, it means the frequency is getting bigger. And the bigger the frequency, the shorter the distance or its wavelength. So HF is also not too clear, but in the aviation industry, we use it a lot, especially communication over the ocean. And you know, in this world, we have 70% water and we have 30% land. So most aircraft actually fly over the ocean. And because we cannot physically put a transmitter and receiver in the ocean, we use the HF a lot over the oceanic communication because the signal can go very far. But on the ground, when we can put a transmitter and receiver, we use a VHF antenna and receiver. And the FM falls in between here, the VHF. And of course, for TV broadcasting and reception, we also use VHF and UHF. So in TV broadcasting, the audio part, we use FM, which is 108 megahertz. And the picture part, we can also use VHF and UHF. So VHF says that the bandwidth is between 30 to 300 megahertz, and UHF from 300 megahertz to 3 gigahertz. And of course, for satellite communication, where the bandwidth for is between is above 30 megahertz. Above 30 megahertz, we can avoid the use of satellite space propagation. But in particular, between 3 gigahertz to 30 megahertz, we use for satellite communication. What are some of the classification of wireless communication? As I have mentioned, we have 3 categories. We have radio, we have microwave, we have infrared. So at this point, I see we have about 15 minutes more. I'm sure we can end here and continue the discussion later on. But in the meantime, I'm sure most of you friends will have questions to ask. So let's end the slides here at the classification of wireless network that will continue some other time. So it is time to ask questions. So please, as said at the outset, if you have a question, you can raise your hand electronically, and then you'll be called upon. Then you unmute yourself to talk.
Yeah, thank you so much, engineer. So class, time to ask questions. Please keep your questions coming.
Unless my friends want to say that they have understood everything that was said.
That is perfect. So they have a quiz on it the next time we meet. So keep your questions coming.
So if questions are not forthcoming, I'm sure we can go on a little bit. Oh?
Please, are there any questions?
No, please.
Hey, speak for yourself. Oh.
Any question?
Okay, so then let me do the question. Let me ask the questions. Since you are not asking questions, I'm going to ask questions so that if you have the answer, you raise your hand. What is a transmission medium? What is a transmission medium? If you know the answer, you feel free to raise your hand electronically. Elijah Apreku, you can kindly unmute yourself and speak, please. Sorry, Elijah, unmute yourself again, please.
Please, a transmission medium, as you said, is anything that carries information from one source to the other.
Exactly. But can somebody define, as we go forward, let's try to distinguish between simple English, telecommunication English, communication English, so that at least we are shown as students who can use technical jargons in our explanation. I see the hands of Evelyn Kumsa. Kindly unmute yourself and express your contribution as well. You can kindly unmute yourself.
Yes, sir. Sir, please, transmission medium is a means by which a communication signal is carried from one system to another. And you said it can be found below the physical layer.
Thank you. So I was just using that one to explain to you a certain understanding that the physical layer is layer 1. And if the transmission medium is below the physical layer, anything below 1 is what? 0. That is why I said that then it's below, it's the layer what? 0. Of course, we don't have anything called layer 0. So Elijah was earlier on correct. Any thing that can carry information from a source to a destination. And the source can be a transmitter, and the destination is a receiver. That's very good. What are the types of transmission medium do we have? What types of transmission medium do we have? You can mention it and say a little of what you know about it. First, you can just give the distinction between the types. Felix, please, kindly unmute yourself and speak.
Hello, sir. We have the guided medium and the unguided medium. For the guided medium, it uses a physical medium to transmit its data, but for the unguided medium, it doesn't use the physical medium. It uses either infrared, microwaves, or radio waves for the transmission of data.
Exactly. So can you then give some examples of the guided media that we talked about?
We have the copper media. Then under the copper, we have the coaxial and the twisted pair. Then we also have the fiber optics for the guided media.
Very well. Nice one. Nice one. Very good. Hey, you people are really paying attention. Please, what are some of the criteria to choose a network media? If you want to choose which network media to use, what are some of the criteria you need to consider in choosing a network media? Ruben Mensah, kindly unmute yourself and speak.
Okay. The distance the media can successfully carry a signal, and also the environment in which the media is to be installed, and the amount of data, and lastly, the cost.
Very well. The cost of the media and the cost of installation. Very well. Very good. Good, very good answers. What about some of the characteristics of a transmission media? So you see, when you want to talk about transmission media, there are some characteristics we need to have in mind. And these characteristics will help us to even compare them. And again, it will help us to know which of them to choose to use. What are some of the characteristics of a transmission media? Elijah, sorry, Ruben, is this an old hand or a new hand, a fresh hand?
Okay, sir. Some of the characteristics.
Before you go on, Ruben, may we hold on a little bit to see whether any of your friends want to attempt this question? Since
Okay,
Ruben has spoken, can someone else help us about the? Elijah has also spoken. Can we see a fresh hand? Good. Joshua Ajiman Kusimenu, please fire. Go ahead, unmute yourself and fire.
Please, one characteristic is the bandwidth and also cost. So that's 2.
Good. So what can you say, Joshua, about the bandwidth? What is the bandwidth?
Okay, the bandwidth, it refers to the rate supported by the network connection. The rate of transmission.
Nice one. But who can give us a more cocoa understanding of bandwidth? More simpler definition of a bandwidth. Who want to try a more simpler definition of a bandwidth? I keep seeing the same hand though. Can I get a new hand? Well, let's call on Elijah then. Elijah, you have put your hand down. I saw it. I know Ruben is on standby for further characteristics. That's why I didn't call him. Elijah, please. What is bandwidth? Kindly unmute yourself.
Please, I would say the bandwidth is an information carrying capacity through a medium or a channel.
Good. So let me just fine tune it a little bit for you. Is the information carrying capacity of a transmission medium. That's all. The information, how much information that that particular transmission medium can carry at the time. Good. What other characteristics? Our friend mentioned cost and bandwidth characteristics. In the next 5 seconds, if I don't see any hand coming up, I'll be tempted to call Ruben again. Unless
Odumja, John Peters, Bettina, what are you people online doing?
I should do random calling. All these friends are shy of me. I hope these friends are not shy of me.
Marco. Chris Maru. Chris Maru, yes, go ahead. Unmute yourself.
Okay, madam, concerning the EMI.
All right, what can you say about it, Chris Maru? I like that. What can you say about it?
Talking about the STP and the UTP. The STP has this magnetic to prevent to resist it from EMI forces.
Right, nice. So fine-tune it a little bit for you. The STP has a braided wire mesh that serves as a return to Earth, shielding external electromagnetic interferences affecting the main signal. But please remember, it itself is not totally immune, but compared to UTP, it is a better EMI resistor than UTP. Very good.
And also the installation. Yeah, some might be easier to install and some too very difficult, such as the fiber optics.
Good. So TechNet, TechNet, which is more easier to install, Chris Maru. TechNet, TechNet, which is more easier to install.
I think the TechNet.
Good. 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 Now, Zara, this question is for you. What is the difference between baseband and broadband? You asked this question earlier, so I'm sure you got it now. So let's see whether you really understood it. Zara, what's the difference between baseband and broadband? Is Zara still connected? Zara is gone. Wow. Is there anyone to help us get the understanding between baseband and broadband? Yes, Felix, please.
Please, for the baseband, it's the common operation of, is the most common operation used, and it deals with using the entire bandwidth for a single communication channel, whilst with the broadband, it dedicates its bandwidth to multiple communication channels.
Exactly. Exactly. So if I am the one to examine you friends in an exam, and I say write short notes on baseband and broadband communication, or how do you, what is broadband, what is baseband, or contrast between baseband and broadband communication? If I am the one to examine you on, and you can draw a little picture to add up to your answer, you score the maximum mark. I'm sure you get what I'm trying to say. You score maximum mark. All right, that's very good. Now, what is attenuation? which is a characteristics. No one has talked about it yet, so I've mentioned it. Elijah, please.
Sir, please, attenuation is the gradual reduction in signal power as the signal passes through a channel or a medium.
Very well. Well, all right. I think our time is up. So at this point, I would like to take a wonderful picture with all of you, and especially if your background, it's okay to put your video on. You can kindly do so now. If your background is okay and you are comfortable to put your video on, you can please put your video on now. I will take a picture for all of us. I'm waiting. Okay, so the rest whose pictures, videos are off, they are shy. All right. Hey, where is my shortcut button?
Engineer, you got a picture?
The button, print screen button seems not to be working all of a sudden.
Oh, shit.
Just a second. Let me use this. Okay. I use the snapshot, the snapshot. So I've gotten it now.
Okay, take it.
All right. So this is the end of the class. I really appreciate all your support, contribution, and your attention. We'll meet soon.
And engineer, we want to say a very big thank you, taking time out of your very tight schedule. Aviation people are not seeing you this morning. Thank you so much for making it to our session. Thank you. We are very grateful. Yeah.